All right, now let's look at what we have before us. We are still on the raw number system, but this time we are going to look at how we can express some numbers in standard form. In other words, we can also say scientific notation, exponential form, or index form, whatever you are asked to express any number in such forms. That is what we are looking for. Now, in standard form, when you are asked to write a number in a standard form, it should be in this form, that is p dot q times 10 exponent n. Now, there's a condition here where p is greater or equal to 1 but less than 10. It means that whenever you are asked to express certain numbers in a scientific notation form or standard form, your p must be either 1. Your p must be either 1 or 9. Have you gotten that? Good. It means your p shouldn't be less than 1 and shouldn't be greater than 9. It should be from 1 to 9. That is what it means. Now, what does the Q here stand for? The Q here, most of the time, we may ignore, depending on the question that will be given to you. You also need to bring it sometimes. Now, the Q here, these are the numbers after the decimal point. So, these are the decimal numbers. Have you gotten that? After the number, after the point, those numbers left, they represent the Q. And my n, so we can also say the n, where the n is also an integer. Now, when we talk of integers, we mean what, both negative and positive. So the n can be a negative. It can also be what, a positive integer. But the n, the number of decimal numbers after the point will determine what will be written for n. Have you gotten that? Great. So let's not waste time. Let's take an example. For instance, if I give you this number, let's say we have 4, 2, 3. If I ask you to express this in a scientific notation or standard form, this is how you write it. So it means that we are going to express this in this form. All right, in this form. Okay. So what we do is we make sure that the number here, there's a number which represents the p, and we can also get a number representing what, q, and also a number representing what, n. So this one, I can start by moving from here because the number starts from here and ends here. So I will start by moving from here 1, 2. So when I get here, because I want a number to be what, p. So I will end here, then I'll write my 4, then I'll bring my point. Have you gotten that? Now after the point, how many numbers left? So I have 2, 3. Then times I bring what, my 10. But how many numbers after the point? 1, 2. So I'll write my 2. But whether the 2 is going to be a negative or a positive, because we are saying that the n is an integer. And as we know, integers consist of both negative and positive. So this time, we are going to write positive 2. So it's supposed to be 2. Why? Whenever you are moving to the left side, all right, when you are moving to the left side, your n becomes positive. But when you are moving from the right to the from the left to the right side, your n becomes negative. So this time it is positive because we moved from left to right, from right to left. Sorry. Yes, so this time we moved from right to left. That's why we are getting what? Positive. Have you gotten that? So you ask yourself, the P, because there was a condition here, the condition says that P should be greater or equal to 1 but less than 10. So you ask yourself, this represents our P, and the numbers here represent the Q, where my N is the 2. So you ask yourself, is the 4, does it satisfy this condition? Yes, because we are saying that the P should be from 1 to what, 9. And looking at 4, we can find 4 here. So it means this is right. Okay, good. So when you are asked to express a certain number in a standard form or scientific notation, this is how you do it. Let's take another example. If I give you this. Now this time we counted from the right side to the left side. So this time I'm going to give a question where we will be counting from the left side to the right side. So let's say I have this 0.00324. Great. Now let's see. So whenever you are given this and you are asked to express this in a scientific notation form or standard form, you see where the point is. There is a point here. So we start counting from here where the point is. So we move 1, 2, 3. Now the point should be between two numbers other than 0. Two numbers other than 0. If there are zeros here, then the point should be between what? Numbers other than 0. So looking at this, we have the point here. So I'm going to ignore all this 0 and write my 3, then 0.24. But how many did we count? So 1, 2, 3. It means that I'll multiply by 10 exponent what? 3. But you ask yourself, should the 3 be positive or negative? We counted from the left to the right, so we are going to get what? Negative. Have you gotten that? So that is how we express numbers. When you count from the left to the right, your N should be what? Negative. If you count from the right to the left, your N should be positive. So take note of this. Have you gotten that? Great. So this is very simple. Let me give you more examples. Let's say we have 4, or let me write 5, 0, 3, 4, 5, 6. Now this is what we have. So this time, are we going to count from right to left or left to right? Yes, we are going to count from right to left because we don't have zeros starting from what? 0. We start from what? Raw number. So we start counting from here. So let's count 1, 2, 3, 4, 5. So we end here. The point should be between what? Numbers other than 0, even though this is 0, but once the 0 is between two raw numbers, then the point must come between them. So we are going to write 5 dot, my 0 will come 4, 5. Are we supposed to add this 0? No, we can choose to ignore it. Have you gotten that? Whenever there's a 0 which is not between two numbers, we ignore them. But when the 0 comes between two numbers, we repeat that 0. That's why here you see that the 0 is between 5 and 3. So I brought the 0. The second example, the zeros were not between real numbers. That's why we ignore them. Have you gotten the point? Great. Then times 10. So how many times did we count? We counted 1, 2, 3, 4, 5. So it means I'll bring my 5, and this time it should be positive because we counted from the right to what? The left. Great. So this is very basic. Now, what if you are given a scientific or standard form and you are asked to change it to raw numbers or numerals? Let's say, so let me use the same examples. Okay, let me use the same examples. So let's say we are changing this time, we are reversing it. So first we change from numbers to standard form. Now this time we are going to change from standard form to raw numbers or numerals. So I will use the same example. So let's say we have this 4. Good. Now you have this and you are asked to change this to numbers or numerals. How are you going to do this? Now, you see, whenever there is a point here, have you gotten that? All that you do is great. So whenever you are given this, now you consider the n. Have you gotten that? So you ask yourself, the n, is it negative or positive? So when you identify that it is positive, what you do is then you consider this number. So it means that if it is positive, then you are going to start from where the point is and move to the direction of what the right side, or you move to the right side direction. Have you gotten that? So it means that you are going to start from where the point is and start counting how many times? 2, because it is 2. It is positive, so I'm going to count from here. That means I'm moving this point from here. So I'll move here 1, 2. Where does it end? So it means this time my point will not be here, but the point will be here. Then I will get 423. Since the point is here, then I ignore it. So this gives me the answer. Listen again. I said that whenever you are changing this, what you do is consider the n. We already know that this is the n, that's the integer. Ask yourself whether it is negative or positive. If it is positive, then you start from where the point is. You are going to move how many times? 2. You are going to move 2 times, moving the point from where it initially was. You move it from that point how many times? 2 to the right. Have you gotten that? And that's what we have done. Now let's take the second example where we have 3.24 times 10 exponents negative 3. Good. So this time, you ask yourself, the n, is it negative or positive? It is negative. So if it is negative, it means that then this time you are going to move the point to where? The left side. Because when it is positive, we move the point to where? The right side. So once it is negative, then we are going to move the point from wherever it is to the left side. But this time, how many times? 3. So we move from here 1. So we move from here 1, 2, 3. Have you gotten that? But after moving, you realize that we don't have any number here. We don't have any number here. So what you do is places where you don't have numbers, you replace them by zeros. So it is going to be 0 here, 0 here. Then I'll bring my 3. But this time the point has already been moved from here. So I'll add my 2, 4. But this time, because we are moving and going this side, so you bring the point here because the point ended here. So once the point is here, then you add another 0, making 0.0032. So you see that it will give you the same thing. Have you got my point? Great. Now let's try the third example. So this is what we have. This is what we have. Good. So let's look at how we can change this to real numbers. So this time, let's identify, is it positive? Yes, the n is positive. So it means you are going to move to which side? The right side. So we are going to count how many times? 5. Okay. So this is what we have. So we are going to move from where the point is to the right side, but how many times? 5. So I will count from here 1, 2, 3, 4. Then I'll add another one, 5. So this time, the point has moved from here to this point. But do we have any number here? No. So what do you do? I say when there is no number, you replace that empty space with what? 0. So I'll write my 5, 0, 3, 4, 5, then I'll add my 0, then it ends here. So you realize that when you do that, it is going to give you what? The exact number. So that is how we write numbers in the standard form, and how we can also what? Reverse it. So in our next lesson, we are going to look at how we can add and subtract standard form whenever you are given numbers in the standard form and you are asked to add and subtract. Okay, and remember, we are going to base on this how to reverse standard form to real numbers. We are going to use that in our next lesson to add and subtract what? Standard form. So let's meet next time for our next topic. Thank you.